Hi there, I'm the Duke, and this is the series in which I'm streaming. I'm a computer programmer. I'm a front-end developer. That is, and I'm trying to learn a lot of different and new skills and technologies. So I'm just streaming what I'm doing and what I'm learning. First things first, I have a couple of things to mention. This is my new wallpaper. For some reason, I really like this strong pinkish and bluish hues, the street light lamps, and this aesthetic. It's really pretty. It's My friend actually saw this wallpaper and he says it's tiring to his eyes, but to me it's nice. It's appealing. It's visually great. I also have if you are watching me, you also know that I'm using my tablet as well. So my tablet also has a new wallpaper. Liminal spaces. All right. So um, before I continue, I just wanted to mention something, and that is the fact that I'm I'm doing things slow, and I don't want to do things slow. So basically, I'm gonna try to now go through the sections and through everything that I'm learning a bit faster, right? A bit faster. So that's it. I'm not gonna bother you anymore. Let's go. So what we did, yeah, I'm starting with C. I want to finish this project before I do anything new. Uh, it's not exactly something that I don't say I don't want to say appreciate. Just it's a bit boring as of late. So let's try to wrap this up. Um, okay. So what we did is we are following. I'm actually following a book by a really great programmer named Daniel Holden. The book is called Build Your Own Lisp, and I'm trying to build my own Lisp uh, accordingly with some not a lot, but with some of my own innovations. This chapter now is about conditionals, so about comparisons between uh, different statements and branching of tasks and logic. So let's do this. So what I did already is I think I defined some new built-in functions for the comparison methods, such as greater than, less than, equal to, and all the other comparison operators. I didn't do this the last time, but I'm gonna do this now. Is the fact that I'm trying to define an if function that will test for some conditional, and also we are going to evaluate some code based on the logic of the function. Let me just find the methods that I already created. Built in here. What? Oh, just a second. I just realized my stream is private. Okay, I think now it's gonna be okay. Okay, so what I did here is the following. I have created already some of these built-in comparison methods. We have greater than, less than, greater equal, and less than equal. So all of these are the new comparison methods. So what actually are we using here is we are using our Lisp value data type, which is a structure that we are using as the basis for all of our types in the language that we are writing. So here we define the method, then we are calling the built-in order, which will be this is just basically an abstraction, an encapsulation of the real logic which will be found inside built-in order. Okay. So these are our ordering functions, and they will only work on numbers, and we only want them to work on 2 arguments. Okay, so these are the wrappers. Now here is the real logic. We checked for error condition first, and then we compared the numbers in each of the arguments to get the results that we want. Now, let's talk about equality. Equality will be, and this is the equality method for comparing 2 Lisp value structures in our language that we are writing. Equality is going to be a bit different, a bit complex. So because here we only compared number types, but equality should work and should work on a lot of other types. We want not only to compare numbers, we should also want to compare equality between different types of Lisp values, lvals, or compare against empty lists, or even compare 2 functions between each other. Okay, I don't think that there's a good way to write. Okay, here is a question in programming language design. When implementing equality functions, what is something to keep in mind? When implementing a equality function in a programming language, here are some considerations to keep in mind. Equality semantics. Decide the type of equality the function should check. Yeah, this is actually what I mentioned. So we can either check against reference, where we check whether 2 objects or values are actually the same instance in memory, or between value if they have the same properties inside. Also, we have precision and tolerance for floating point numbers. We can also handle different types, data structures, and okay, these are all actually ensure that equality is symmetric. If A equals B, then B should be equal to A. I mean, this makes sense. Should also be reflexive and transitive. We should also handle null or undefined values. Nice. So let's without further ado, let's code this. First snippet here checks whether the types are different. If x type is not equal to epsilon type, we are going to return 0. So immediately we are canceling the equation and failing it, actually returning not equal. Now, numbers are just compared. Symbols are just compared, but they are compared because they are string behind strings, array of characters behind the scenes. So we need to compare their string values, errors as well. Now, here we stopped the last time. Let's talk about functions here. All right. So let's talk about functions. How can we compare functions? How can we compare functions? If the x has a built-in, or if the epsilon Lisp value has a built-in. In this case, I should just return the built-in compared like this. Otherwise, so what is the built-in method? The built-in method is one that is created with the environment on running the application initially. So these are not user-defined. These are defined here. I mean, they are defined by the user. They are written by the developer, but they should be instantiated once. They should be built in actually in the programming language. But where are they? I remember. Here they are. These are all the built-in methods. So they're actually checking whether whether these are equal. Okay, if they are not, now what should happen if they are not equal? What should happen if they are not equal is the following. We should make sure that the formal argument are equal and that the bodies are equal. In the end, these are just lists of characters, and list of characters are represented by Lisp values in our implementation of the language. So that's this. That's that. Okay, now how can we compare Q expressions and S expressions? So how could I do this? Now this is a thought experiment. I have the solution, but I would like to think about it. So I should iterate through the Q expression or the S expression and compare every individual element in it. So for oh god. I just finished my workday and let me just remove this. So I just finished my workday and my brain is stuck on TypeScript mode. Int. But I can do another thing here. I can check if x count is equal. It's not equal to epsilon count. In this case, what am I doing, man? In this case, 5, 3, 4. In this case, return 0. Right? Makes sense. If they have different number of elements here, if they have different number of elements here, yeah, they shouldn't be able to do this. So otherwise, if L will equal x cell at I index and epsilon cell at the I index, but I shouldn't check whether they are equal. I should check whether they are not equal. What have I done? What am I doing, man? What am I doing wrong? Here? What am I? Is this okay. If they are not equal, return a 0. So that should be it. Otherwise, return 1. I should also break the switch statement. What is this one? What? No, this one shouldn't end this. It should end this array. And this, yeah, should end the big guy. Like this. Oh, it seems like I have an extra. I think now it's okay. Okay, this should be fine. Now. Now. Look at this. We need to add. Need to add equal and not equal. And I can do this by leveraging some of these methods that we have written. So I need to make sure, okay, let's not think about what do I need to do. I need to compare, let's say, two what do I need to do here? I need to leverage this method. Basically, I need to create, I need to use, what have I done here? Why is this small? Move it to 20, not 21, 20. So I need to leverage this method. And next, when I write, I don't know, expression 1 equal wait, how is written? It's written, it's written like this, expression 2. I should hit this. Okay, let me think about it. Let me think about it. LL built-in compare. What am I taking? I'm taking the environment. I'm taking the Lisp value. I'm taking the character for comparison. Make sure we have two elements. I have here somewhere the Lassert count. I can jank it. Have I janked it? I hope I did. Count. Wait, what is this method called? Here. Paste it. Nice. I'm just gonna change the string. Here we are gonna use the operator from the arguments. So what will I do here? Let's create a response flag if string compare, if the operator is equal to double equals, and if it's this operator. So what am I gonna do? L will be L will equals a, the first element in A, and the second element in A Otherwise 556. If string compare if the operator is not equal, this. Let's delete this guy and let's return the number. EA this, otherwise it's not equal. I'm just gonna do the same thing, but I'm gonna use the not equal operator. Okay. Let me just think about this one more time. Okay, sorry, I wasn't thinking about the project as much. I found my old mechanic keyboard here and I want to connect it to see how it runs. Let's see, hopefully I don't need to install anything. Okay, I see some lights. Okay, I forgot I need to unlock it, but how do I unlock it? No. No. How is it working? Okay, let me just check if I messed up my stream. Hopefully I didn't. Just a second. If I keep on speaking. Okay, it works. Why isn't the keyboard working? So how is it called? It's a basic. It's an old white shark. Let me see. It's a white shark. White shark keyboard. How to use? What's the name of it? GK 2022. Ah, okay. So function. Oops. So function and down. No. Function and down. Okay, now the keys are still not working. Okay. It's gonna take some using two, but I think I should be right. So we have our operators. We have our comparison operators here. But at the same time, we're gonna need any function, and this function, if you already know what it does in other programming languages, upon some condition being true or false, it evaluates one thing or the other thing. So let's do this. Oh god. Maybe. Where's this character? I already forgot. Where's this character? Where's this asterisk? I don't believe this. I basically forgot where. Ah, here it is. LL. Built-in if. Length. E. A. So let's create the if operator here. So we created a function, but now let's create some assertions. So this guy should have 3 children, right? It should take the elements to compare with and the comparison the comparison symbol. Next thing, let's make sure the type is correct. First element and the type of the first element should be a number. type of the second should be a co-expression. Type third one should also be co-expression. So what should I do now? I should create a new Lisp value. So the two guys that are being compared against, the type of them should be a nuts expression. Let me just copy this guy, paste it here. So if the conditions of a comparison are true, we are gonna evaluate the first expression. Otherwise, let's evaluate the second one. Lastly, let's delete this and let's return the X. Now we should just be able to. What have I done? I didn't want to do this. How can I search? I need to do this, and then I can do add built-in. Oh, I made a mistake the whole time. I was using regular Vim instead of NowVim. I like NowVim because it lets me search with style like this. Nah, no. Then add here. Here's where I want to be. My boy, here's where I want to be. Here, can I paste this? I think I need to open the visual and then I can paste it. Yes, So in Vim, how to indent multiple lines of code. Let's see. So I can use like this or like this. Let's maybe 742 all the way up to 746. Let me just take another look, sorry. So it's 742, 746, and then I have this. Okay, nice. Let's see. So what happened now is I registered all of these methods, and hopefully now, let's split this. Functions. Yeah, I think this is it. I should just be able to write the functions to conditionals. Okay, how many errors will I have? Oh god. Good. Built-in add. Okay. 11. Let's see what's happening here. 470. Okay, I think I know what's happening here. How can I copy this whole line? And then I need to see where I did my forward declarations at. All the way. 55. Yeah, it's here. So paste. No. What have I done? Paste. Ah. You must be kidding me. What have I done? This wasn't here, right? I don't think this was here. I'm gonna remove it. And I'm gonna search for lol. Oh no. Built-in order. And then I'm gonna copy this line. This is the line that I want. 1, 2. Then I'm gonna go 58. 58. And here I should paste it. Remove. Move to the end. Remove this character. How can I remove only one character in Vim? I know how to remove a whole line. But how to remove only one? Ah, the X. Okay. Let's save this. Okay, how am I switching between the tabs? Ah, with the tab. Okay. Let's try to do this again. 483. 483. Oops. So first thing, this guy is incorrect. This should be like this, because this is less than equal. Yes, let's save this. Let me check if anything has changed. I'm not very confident it isn't. I need this. Save, build again. Expect what? 491 int return. This shouldn't be a return. This should be only the R. This should be only the R. It built. Oops. Conditionals. Let's test. 10 greater than 5. So it's 10 greater than 5. This less equal 8850 is 5 and 6 equal is 5 and an empty q expression equal 1 and 1 is equal. It's not equal and yeah. Now is this equal? 1, 2, 3, 5, 6. 1, 2, 3, 5, 6. No, it's like 5, 6. X epsilon 100, 200. It's an empty method if X and epsilon are equal. X epsilon, otherwise minus X epsilon. Amazing. Now we have conditionals here. Now we have conditionals. What have I done? No, I just wanted to remove the search from Neowin because it keeps it stuck. How can I clear it? How do I clear the Neowin search? Starting with all my everything that I searched for is selected. Oh, so it's okay. Okay, so it's the command to clear the search highlights in Neovim. We are using NOH, and by pressing enter, it should clear everything. So okay, let us just now mention recursive functions, which, first of all, we created conditionals and we actually made our language a lot more powerful. because by default, they're going to let us implement recursive functions. And those are the types that call themselves. The only thing that we need to add is termination case. Let me just do this. Yeah. So recursive functions. And this is something that works. Let me just remove this. What is this? So I should have fun. Len all if L is equal to an empty object, I should return 0. Otherwise, I should return the last element. Oh, this is so ugly. And it doesn't work. Why? Symbol not found. Fun. Do I have the symbol fun here? Fun? Ah, I think this is I think I know what the problem here is. Fun. I think there is a built-in method that I didn't implement myself that actually creates functions a lot more easier than using the full syntax. It's like a syntactic sugar for this variant that we are building, but I'm just checking to see where it is. Wait. Actually, do I just need to define it? No, it doesn't work like this. It works like this. I define it here, and now this works. So basically, what happens here is the following. This is some method that's first been defined using this syntactic sugar-like structure. So this is the method in which we are implementing a function called len. And this function tells us the number of items in a list. If the list is empty, we return 0. Otherwise, we return the length of the tail of the input list plus 1. So we are repeatedly using the len function until it reaches the empty list, and then it returns 0, and then we add all the other results together. Okay, so we have a base case. Then we take a chunk of it We put this chunk aside, we come all the way to the base case, and then we come back up. Nice. I like this. I like this. I really like this. So this is done. Today's episode. Let me just save it. Ah. There's one other thing that I wanted to do, and that is the following. Just a second. I can close this, I think. How can I close this? Control Shift V. Okay. This, I don't think I also need this. Let me just take a minute to get some water and to refresh myself, and I'm continuing.